Good day everybody and welcome back to my channel. I've got some good news. I'm going to start a different project, one that I've actually been planning on getting started on for a while, but I'm finally getting around to it. It's actually going to be a dual project because I'm basically building two of the same thing at the same time. Amplifiers, big amplifiers, 500 watt amplifiers, 4 ohm stable. So this is stemming back to an amplifier that I built some years ago. I started making small little modifications to it. Like, it was still a work in progress. I got it up and running. I remember I was playing around with the negative feedback values, just a few little things, and I remember changing driver transistors and playing around with Miller capacitor values and getting it about where I wanted it in terms of those things. And then I was going to build a proper preamp section for it because the front end, I hadn't actually designed a proper front end for it yet. And then I decided I wanted two of them. And what I did was I took basically a really quick schematic down of what I had, well, I thought I did, and then built two based off of that schematic. And I'm just trying to think back how on earth I smoked two amplifiers, because, I should have used a dim bulb or something. It was something really stupid. I think I had both the transformers wired together on one cord. And I think because I'd copied the design, obviously I wouldn't do something like that these days, but back then, silly Dave moment, I remember now, I had two sort of like lamp cords, figure eight sort of cable. Not figure eight, it's in a jacket, but you know what I mean. Anyway, twin conductor in a sheath. I had two of those going to the power transformers, and they were just going, I can't remember to what, into a plug. They were going to the one spot at the other end. Anyway, I turned it on, bang. Not bang, it was more of a snap, crackle and pop with a smoke show. But let's just say that basically what I did is I put the driver on the NPN side, in the PNP side, and the driver for the PNP side ended up in the NPN side. I also put a diode around the wrong way too, and yeah, that didn't work out too good for the amplifiers. Anyway, the thing that sucks is all I had to go off of was a couple of schematics I found lying around, which both had errors in them. Also, neither of them had any of the values. That's the other thing. There was a current source and a current sink that I had not noted down values for. So Miller compensation capacitor values, current source, current sink, resistor values, and the transistors I used, that sort of thing, and feedback network values, and the front end. So that was where I was up to. And then I smoked the whole driver buffer output stage, and I just ended up, that's right, I was also out of transistors too at that time after I smoked the last lot, because I'd run out of transistors by then. So anyway, that stayed just sitting there for a while. The problem is, like I was just saying, I had literally bugger all to go off of. So what I did is to the best of my discretion, looking at the old drawings I've got and what was left of the build, which was basically a prototype, because what I wanted to do is I wanted to just be able to power it up and sit there and just, tack in and out different component values with my iron until I got it right. And then I was eventually going to make it up in some other sort of fashion, like on a board or something. Anyway, I never got that far. But I have reverse engineered the mess that it is and the drawings that I've got, and I've come up with this. So there are things here that are missing. Like I said, the Miller cap values are not in there because I don't know what they are. I don't think there was anything done to the output transistors in terms of Miller compensation, but the values that are noted down are correct. Oh yeah, base resistors too. I'm not too sure. I might stick an ohm or something like that in there. I haven't thought about that yet. This is everything that I could find to start off with. So it's going to be a cool project because I've got enough here to build a working amp. I've had a look over this and this will definitely work. So we can build a working amp and then play around with stuff and finish it basically. So it's actually going to make for some good videos because there's still some design work to be done. What on earth was that? Sorry, give me 1 second. Okay, sorry about that. That just really perplexed me. It's 2 o'clock in the morning. My cat's meowing and I thought I heard someone outside. I think it's just some people just being loud across the road in the car park anyway. So the output comprises of two 2SC 5200s, two 2SA 1943s, 0.22 ohm 5-watt emitter resistors, 2-watt 200 ohm resistor between the bases to stop, what do you call it? Cross distortion. Not crossover distortion. You know, when you run a high frequency signal into it and both the transistors have a tendency to stay switched on at the same time, you've essentially got current flowing through it. I forget what it's called, but that's what that resistor and that resistor is for, to deal with that. That is supposed to be 200 ohms. That is supposed to be 820 ohms. The Zabel network, 47 ohm 2-watt resistor, 100 nano 100 volt film going to the 0 volt rail from the output. Then there is a 9-turn 1.25 millimeter coil, which comes out to 3.3 microhenries, alongside or parallel with a 4.7 ohm 5-watt resistor, and that's the output. Coming back, that's driven by a pair of tip 41, tip 42C with Miller compensation capacitors, 10 ohm base resistors, 1 watt. I've just drawn a symbol for a current sink and a current source because, like I said, I still got to determine the values. It's that many years ago. These are the only things that I could work out from what I've got and what I had in memory. I don't have the current sources built, and I do not remember what transistors I was planning on using, so that's something we're just going to have to design from scratch. It's not very hard, pretty simple thing. Okay, so the resistor that goes across these bases, 820 ohm. Then, what do you call it? After the current source and current sink, there's a 10 ohm resistor on each side, going to the collectors of, what were they? I didn't write it down. My apologies. They were 2SA 1024s and 2SC 3206. 2SC 3206. Oops. It's getting really late. That's my excuse, alright? 2SA 1024. I should have gone to bed, but I just haven't got anything done on my channel for quite a few days, and I just really wanted to get something done. And I've gotten this far, so I thought I might as well continue with it. I will be going to bed after this, however. Anyway, yeah, so those transistors are a 2SC 3206 and a 2SA 1024. Reverse diode across the bases, 100 nano disc ceramic of some sort, a 4.7 microfarad electrolytic for the bias, and then we've got a couple of 500 ohm pots with 33k resistors going to them from the collectors, or should I say the collector and 10 ohm resistor junction coming off the current sink and current source. These are for adjusting offset, incidentally. The bias is set over here. So this, I could have drawn this around this and put this in the center of the page, but the thing is, because I was trying to reverse engineer I'll show you in a minute what I was reverse engineering. It'll make more sense, because I was reverse engineering multiple sheets of paper that literally just had very messy, like, if you think this is messy, you should have seen my writing a few years ago when I wasn't even putting effort into it. It wasn't good. So I had to try and read that, make sense of it, and make sense of a scrambled mess of circuitry that's half pulled apart. So I tried to just do things in sections so that I didn't get too confused. And now I wish I did it the other way, but anyway, it's all good. Basically, what's going on here is there's some TO220 device diodes that get mounted directly across the top of these transistors on the heatsink. So I'll show you in a minute when I take the phone over to the old amps. Those diodes are thermally coupled to the output devices. I'll point this out too. These 1N40007 diodes are before these diodes. These get soldered next to the buffer transistors. So on the PCB, there will be, the hole where the base pin goes in from that buffer. Right next to it, there'll be, say 1 millimeter or 2 next to it, another hole that's connected to the base, and that diode will be coming out of that hole, so that it'll be standing up next to the transistor as close to it as it can be, and also attached by one leg, just to try and get it thermally coupled to it. It's not really that much of an important thing, but I just, it was just an easy thing to do in the design to put it there, so why not? Anyway, coming back, this end goes to the PNP buffer base, so it gets tied to here, and this leg gets tied to here. And then on the other end of the diodes, there's a couple 120 ohm resistors, and across that is a 560 ohm resistor on a 500 ohm pot coming back on itself. That is how you set the bias. This is what sets the bias level. This is what sets the offset. Incidentally, the input from the preamp actually comes in here too, through a 4.7 microfarad film capacitor and into this center point here between these 220 ohm resistors. And the other side of this 4.7 micro film cap has a 22k resistor going off to the 0 volt rail. Feedback network, like I said, again, just question marks. I know it was, obviously it's in that region, the capacitor was somewhere around 1 to, probably in between 1 and 47 picofarads in reality. 100 seems a bit high to me, but yeah, I'm going to say 47. It's probably in between 1 and 47, and the resistor is going to be somewhere in between 10 and 100k. Something else we'll have to work out in real life. So that's good, because it gives us a little bit of stuff to play around with. But that's what I have for that for now. This is what I've had to go off of. Literally just a mess. All I had left here was a bit of strip board that I'd made up the prototype of the buffer board on, and I ended up, what I did was I wired this up backwards. So basically the NPN transistor was going to the PNP side. If you have a careful look at all these resistors, they're smoked. So are the emitter resistors, so are the transistors. But anyway, this is what I was talking about with the diodes. So they're mounted directly on top of the transistors that they are compensating. So that's how I did that. If anyone's wondering where I got inspiration from for that idea, I actually got that from SAP series transistors. Actually, just give me 1 second. I was going to say, I don't know if anyone's familiar with the transistors I'm talking about, but if you're not, those. So I should just see if I've got the data sheet on my computer for a sec. 1 moment, please. I probably do, and I can show you a lot better what I'm trying to talk about here. Just give me a second. Yes, okay, so I've got it here. I've got the data sheet for the SAP 08 and the SAP 15. Alright, I'll just get the phone so I can show you guys. So, little man, not now. Don't jump up here. No. Sorry guys, I'm gonna have to get the cats out. I've got stuff everywhere in here. Alright, sorry about that. Okay, so this is basically an internal diagram of each transistor and what's inside it. So inside each transistor there's a base to emitter resistor, the output device, the driver, the emitter resistor with a breakout point so you can use your own emitter resistor. I'll go into detail why that's a good thing in a minute. But note here, inside it's got a mixture of normal diodes and Schottky diodes is how they achieved this. But the NPN device has got one diode in it and the PNP has, I think it says here actually if I scroll up and read it, 1 PN junction diode in the NPN and 5 Schottky barrier diodes in the PNP. There you go. And that's how they've got the, the thermal stability so well done. The thermal tracking. So that's where I got inspiration for this idea from. And you know what? It worked out so bloody good. I mean, I'm not surprised, but yeah, I was really happy with it. Yeah, okay, fair enough. It is a little bit expensive using, these are BY229s, complete overkill for what they're doing. But the thing is, I was trying to find a diode that I could find around here at the time quickly that had, you know, a big TO220 mounting tab so I could really get good coupling to the top of this heatsink right literally above the device that's making the heat, you know, and it worked really well. So anyway, that's where I drew inspiration from. Oh yeah, and the reason why it's good to use your own emitter resistors, inside this guy, the emitter resistor that's in there, it's a metal film resistor or something like that. Actually, I think it says in the data sheet here, because the reason I know all this is from reading the data sheet, so it probably is in the data sheet. I'll just pause the video whilst I find it. I found it. The built-in resistor is fabricated with polysilicon on the chip for the SAP 08PN, and a thick film resistor is used for the SAP 10PN and SAP 15PN. Later, the thick film resistor, the thick film resistor has a weaker destruction point in the PC area, especially for large current flowing area, rather than that of the transistor chip itself. So basically what they're saying is if you all of a sudden stick a whole lot of current through the thing and just go beyond the safe operating area, basically, right? Actually, no, sorry. Yeah, so the resistor is weaker than what the transistor will break down at, is basically what it's saying. So if you want to avoid that happening, you can just use your own emitter resistor. Quite a simple fix for that. Quite thoughtful of them to break that pin out for you, I reckon. Excuse me, I was getting a dry mouth. Anyway, that is where I got inspiration for that from. Now, I do have something really interesting. I've been reverse engineering this abomination, which is one of these boards, but the thing is there's all these extra components on here because I was playing around. I added a diode on top of the transistor and a transistor to sense the forward volt drop on the diode, and I was using that to adjust the bias as this thing heated up because it was running a bit of current. It was just a single transistor class A amp, and I was using that to drive this when I was playing around with it. Well, I still got these boards, and I never finished getting the thermal thing on it to work perfectly. So what I was thinking of doing is just taking it off for now, keeping 2 of them, just so I've got something to test this with. And I mean, who knows? I don't know what order this is going to go together in. I don't know how long it's going to take me to get it done. By the time I get the amplifier built, I might have designed a preamp, like the front end stage for it in the meantime and already have something to test it with. But I was just thinking, I've got a funny feeling with the fact that I've already got basically most of the output side of the amp designed, and I've got all the parts and everything ready for it. I just have a feeling I'm going to end up getting all that, like squared off first and be left without something to stick a signal into it with enough power and voltage. It needs to have enough current and voltage to drive the output or the buffer section. So I'll keep a couple of those around to test it. And yeah, that's that. So what I've got to do now is I've got to try and work out how to get these heat sinks off of these bits of wood because they glued down. I don't know what I was thinking. I used to do some really dumb crap when I was younger. Oh God. I've learnt patience over the years, I can tell you that. I'm still an impatient person, but I have a lot more patience than what I used to have. Anyway, and the other thing I noticed, I'm just going to unclip my LCR meter so I can bring the amp over here. The other thing I noticed is that I had gone down to 0.1 ohm. I don't like that, so I've gone back to 0.22 ohm here. I still am an absolute noise head, bass head, whatever you want to call it, but years ago I used to just like making stuff loud. I'll just leave it at that. I like building speakers, I like building subwoofers, I like porting them, I like building crossovers, all that sort of stuff. And with that, obviously, you need powerful amplifiers. And yeah, I was just trying to get as much power as I could. But that is stupid. 0.1 is just really too low for that. Anyway, so that's what we have. I've already got to work actually getting things ready for this. It's just I haven't got to work on the amplifier section over there because as you see the heatsink's glued down, but I have gotten a couple of sheets of circuit board ready. There is 2 sheets here, I can assure you. Okay. To cut out the boards for it because I'm going to need some sort of long strip to go along those diodes that sit on top of the heatsink. I'm going to want another board to mount the output section on, and I'm going to want another board for the preamp driver section. So I've got some PCB to cut out some different shapes, a couple of huge ass transformers. These things do at least 600 VA each, a couple of 35 amperage rectifiers, illuminated switches, fuse holders, a couple of capacitors for the input. They're just 0.22 mic. Heat sinks for the rectifiers, huge ass capacitors, got lots of them, and some fans. So yeah, I've already got things coming along. I've just got to basically get what I can harvest out of that, and some things will go back in my component drawers, other things like the heat sink will get reused, the film capacitors will get reused, yeah, so that's what I'm up to now. So that's what we're going to be doing over the next few days or next few weeks whilst I'm waiting for things to rock up for my other projects like the differential amplifier, or amplifiers I should say. We're going to be building normal amplifiers to listen to music. Alright, well I don't have anything else for you tonight, that's all I've got. I've just started getting this all sorted out, as you can see, so it'll take me another day probably to work out a few more component values and things and to get all that pulled apart and get all my components laid out ready to just start building. I obviously have to make up PCBs too. I think what I might actually do is I might make the output stage board up and the little strip that I was talking about for these diodes that go on top of the heatsink. I think I might make those PCBs up, but the PCB for this section and the preamp, I think we might just use perf board or something like that. And then once we've played around with all the different values and topologies and stuff that I want to experiment with, then I'll etch up the final board, because I just don't want to have to etch board after board after board after board. I just want to get it done in a more efficient manner. So that's the plan. Yeah, I don't really have anything else to say, but I will be back on this, making a video on this within the next day or two at the latest, and I'll get something else to do tomorrow. I might do a little video, you know, building a little switch mode supply on a breadboard, or doing a bit of work on my power supply. I don't know. I'll have a look around, and I'll pick something, and I'll do some little videos on other topics over the next couple of days whilst I prepare for this, and then we'll get into this. Alright, well, thanks for watching, and I'll see you on the next one.